So let's talk about Amazon Aurora because the exam is starting to ask you a lot of questions about it. Now, you don't need deep knowledge on it, but you need enough high-level overview to understand exactly how it works. So this is what I'm going to give you in this lecture. Aurora is going to be a proprietary technology from AWS. It's not open sourced, but they made it so it's going to be compatible with Postgres and MySQL. And basically your Aurora database will have compatible drivers. That means that if you connect as if you were connecting to a Postgres or a MySQL database, then it will work. Aurora is very special, and I won't go too deep into the internals, but they made it cloud optimized, and by doing a lot of optimization and smart stuff, basically they get 5x performance improvements over MySQL on RDS or 3x the performance of Postgres on RDS. Not just that, but in many different ways, they also get more performance improvements. To me, I've watched it, it's really, really smart, but I won't go into the details of it. Now, Aurora storage automatically grows, and I think this is one of the main features that is quite awesome. You start at 10 gigabytes, but as you put more data into your database, it grows automatically up to 128 terabytes. Again, this has to do with how they design it, but the awesome thing is that now as a DB or a sysops, you don't need to worry about monitoring your disk. You just know it will grow automatically with time. Also, for the read replicas, you can have up to 15 replicas, while MySQL only has 5. And the replication faster, the way they made it, it's much faster. So overall, it's a win. Now, if you do failover in Aurora, it was going to be instantaneous. So it's going to be much faster than a failover from multi-AZ on MySQL or RDS. And because it's cloud native, by default, you get high availability. Now, although the cost is a little bit more than RDS, about 20% more, it is so much more efficient that at scale, it makes a lot more sense for savings. So let's talk about the aspects that are super important, which is high availability and read scaling. So Aurora is special because it's going to store 6 copies of your data anytime you write anything across 3 AZ. And so Aurora is made such as it's available, so it only needs 4 copies out of 6 for writes. So that means that if one AZ is down, you're fine. And it only needs to have 3 copies out of 6 needed for reads. So again, that means that it's highly available for reads. There is some kind of self-healing process that happens, which is quite cool, which is that if some data is corrupted or bad, then it does self-healing with peer-to-peer replication in the backend, and it's quite cool. And you don't rely on just one volume, you rely on hundreds of volumes. Again, not something for you to manage. It happens in the backend, but that means that you just reduce the risk by so much. So if you look at it from a diagram perspective, you have 3 AZ and you have a shared storage volume, but it's a logical volume. And it has replication, self-healing, and auto-expanding, which is a lot of features. So if you were to write some data, maybe blue data, you'll see 6 copies of it in 3 different AZ. Then if you write some orange data, again, 6 copies of it in different AZ. And then as you write more and more data, it's basically going to go, again, 6 copies of it in 3 different AZ. The cool thing is that it goes on different volumes and it's striped and it works really, really well. Now we need to know about storage, and that's it. But you don't actually interface with the storage. It's just a design that Amazon made, and I want to give it to you as well so you understand what Aurora takes. Now, Aurora is like multi-AZ for RDS. Basically, there's only one instance that takes writes. So there is a master in Aurora, and that's where we'll take writes. And then if the master doesn't work, the failover will happen in less than 30 seconds on average. So it's really, really quick failover. And on top of the master, you can have up to 15 read replicas, all serving reads. So you can have a lot of them. And this is how you scale your read workload. And so any of these read replicas can become the master in case the master fails. So it's quite different from how RDS works. But by default, you only have one master. The cool thing about these read replicas is that it supports cross-region replication. So if you look at Aurora on the right-hand side of the diagram, this is what you should remember. One master, multiple read replicas, and the storage is going to be replicated, self-healing, auto-expanding, little blocks by little blocks. Now let's have a look at how Aurora is as a cluster. So this is more around how Aurora works. When you have clients, how do you interface with all these instances? So as we said, we have a shared storage volume, which is auto-expanding from 10 gigabytes to 128 gigabytes. Your master is the only thing that will write to your storage. And because the master can change and fail over, what Aurora provides you is what's called a writer endpoint. So it's a DNS name, a writer endpoint, and it's always pointing to the master. So even if the master fails over, your client still talks to the writer endpoint and is automatically redirected to the right instance. Now, as I said before, you also have a lot of read replicas. What I didn't say is that they can have auto-scaling on top of these read replicas. So you can have 1 up to 15 read replicas, and you can set up auto-scaling such as you always have the right number of read replicas. Now, because you have auto-scaling, it can be really, really hard for your applications to keep track of where are your read replicas, what's the URL, how do I connect to them. So for it, you have to remember this absolutely for going for the exam. There is something called a reader endpoint. And a reader endpoint has the exact same feature as a writer endpoint. It helps with connection load balancing, and it connects automatically to all the read replicas. So anytime the client connects to the reader endpoint, it will get connected to one of the read replicas, and there will be load balancing done this way. Make sure, just notice that the load balancing happens at the connection level, not the statement level. So this is how it works for Aurora. Remember writer endpoint, reader endpoint. Remember auto scaling. Remember shared storage volume that auto expands. Remember this diagram because once you get it, you'll understand how Aurora works. Now, if we go deep into the feature, you get a lot of things I already told you: automatic failover, backup and recovery, isolation and security, industry compliance, push button scaling by auto scaling. Automated patching with zero downtime, so it's kind of cool dark magic they do in the backend. Advanced monitoring, routine maintenance, so all these things are handled for you. And you also get this feature called backtrack, which is giving you the ability to restore data at any point of time. And it actually doesn't rely on backups, it relies on something different. But you can always say, I want to go back to yesterday at 4 p.m. And you say, oh no, actually I wanted to do yesterday at 5 p.m. And it will work as well, which is super, super neat. So that's it for Aurora, and I will see you in the next lecture.